Hey, what's going on, guys? Mr. C here. Hope you guys all had a great Easter break. I know that our stay-at-home order got a little extended, so that's kind of a bummer, but it looks like um, hopefully by the end of April we'll be back. We'll see what the governor says. But yeah, I'm going a little crazy. I don't know about you guys. But let's go ahead and continue on. We finished chapter 10 before we left for break. So we're going to be starting a new chapter, chapter 11. And this is basically all about 3D figures. So we're going to be working with cubes, spheres, pyramids, cylinders, stuff like that this chapter. All right. So the first section, 11.1, is going to be pretty basic. We're going to be talking about space figures and cross sections. So let's go over the different parts of, they're going to be called polyhedron, which are basically like 3D polygons. So let's take a look at this picture here. We're going to learn the different parts of a polyhedron. So right here, here's our picture. All right. Polyhedrons are made up of, I'll write the word polyhedrons. So, polyhedron. Okay, made up of three parts, has faces, edges, and vertices. Okay, the faces are basically just each of these polygons. So you're looking at this. This is referred to as a rectangular prism. So we have one face up here at the top. We have one face here at the bottom. Okay, we have a face on the side, face on the back, face on the left side, and face in the front here, okay? So a total of 6 faces, okay? Basically all made up of rectangles. Now the edges are the lines or segments that connect to make those faces. So we'd have an edge here, edge here, edge here, edge here. There's edges going down, and then another 4 edges on the bottom to make the bottom face. And then there's the vertices, which are our corners, or basically where our angles are. For the polygon. So here's 1, 2, 3, 4 vertices, 5, 6, 7, 8 total vertices for this prism. All right. So again, faces, edges, vertices, the 3 parts of a polyhedron. Now there's this formula. Okay, it looks like Euler. It's actually pronounced Euler. Okay. Euler's formula. Okay, and this is for polyhedron. It basically states you can take the number of faces plus the number of vertices in any polyhedron, and this is going to be equal to the number of edges plus 2. Okay, Euler's formula says the number of, and we'll say F stands for faces, B stands for vertices, E stands for edges. Okay, the number of faces plus the number of vertices is equal to edges plus 2, and this is true for any polyhedron. We can go check it up here. Notice the number of faces for this guy is there's one on the top and the bottom, and then there's 4 that wrap around it. So the total number of faces for that one is 6. Number of edges you can see here is 1, 2, 3, 4, 5, 6, 7, 8, and then another 4 at the bottom, 9, 10, 11, 12. So that's 12 edges. And vertices, remember those are the corners, 1, 2, 3, 4, and then 5, 6, 7, 8 vertices. So we can test it out. Again, the faces, so 6 plus the vertices, 8, should be equal to 12, the number of edges, plus 2. And we should have, when we add 14 equals 14, which checks out, okay? So you can see it, Euler's formula taking place in this polyhedron here. This is going to be true for any type of 3D shape. Okay, any type of 3D shape. So, I think that's all I want to go over. Let's just do one that's like an example of what you'll see in the homework, because I know with all the information I gave you, you could probably do it, but some of you like to see stuff in a little bit more depth. So, find the missing number in the polyhedron. Okay, find the missing number in the polyhedron. And let's say I didn't tell you the number of faces, but we have the number of edges. That is 15, and the number of vertices is 9. So even if we didn't have the picture, we should still be able to use Euler's formula to count the number of faces. Okay. And again, that formula was faces plus vertices equals edges plus 2. So faces, that's the variable we're going to be looking for, f, plus vertices, which was 9, equals the number of edges is 15 plus 2. All right. Faces plus 9 equals 17. If we subtract 9 to the right, 17 minus 9 gives us a, what's that, 8. So we should have 8 total faces for that one. All right. So faces is 8. Okay. Hope that was clear. There's only one other thing I'd like to talk about, and we're going to save that for the next lesson. So if you want to go ahead and start the homework on Monday section, feel right ahead, or Wednesday section if you are 10th grade geometry, because you guys are about a day behind. That's why one's Monday, one's Wednesday. Go ahead and do that. We're going to continue on and do the next section of this lesson right now. So last thing we're going to talk about, this is for Tuesdays or Thursdays, depending on what class you're in, is cross-section. So one other idea I want to talk about. This is a cross-section. Okay, and here's a cross-section. This is really difficult to draw, so there's actually going to be a video that I'm going to post along. It's like a minute and a half that I'll have you guys watch. But here's what a cross-section is. Okay, and the video is going to do a lot better job explaining it, but let me just take about 30 seconds to try to explain it for you guys. So, take a look at this picture here. Okay, ignore everything else. A cross-section is basically if you were to take a 3D object and like take a slice out of it, what 2D object would you get? The example I use all the time, if you've ever gone with your parents to the deli, or maybe you've gone yourself to the deli at Meijer or Kroger or wherever, any grocery store, and they have that meat slicer, okay, that deli slicer, that basically you have like a cylinder of cheese or a cylinder of salami or whatever meat you're trying to cut, and that's cutting out, so you have a cylinder, and that cross section, or that cutter is taking cross sections, and you're getting these circle shapes, okay? Now for a triangle, that would look like this. If you had a triangle and you were to cut it, well, this isn't a triangle. If you were to take a triangular prism, okay, and you were to slice it, imagine this is like a guillotine, and you're like dropping it straight down, what shape is that going to cut out of your 3D prism? You can see right here you're getting a triangle, okay? So if you cut this thing vertically, drop this down, it's going to make a triangle. If you cut it horizontally, it's actually going to make a different shape, okay? If you cut it horizontally, and this is really hard to draw, but imagine you cut through here, okay, and you cut this out here. Okay, you'd actually get a rectangle if you were to cut it. Imagine you're slicing this horizontally. Again, this is really hard to explain, especially without being able to see you guys and use an object to explain it. So the video should do a lot better job, but basically that's kind of the main idea is if you were to take a cross section out of the shape, what 2D shape would you get? Okay, so again, the video will clear that up. That's really all I wanted to talk about Tuesday is make sure you guys watch that video and try to see if you can figure out a couple of those for the homework. All right. Hope you guys are doing well. I really miss you guys. Kind of going crazy at home with all this stay-at-home stuff. Parks are closed. Everything's closed. So do miss you guys. Hope you're doing well. Yeah, I think that's all I want to say. Talk to you guys later. Peace.